42 questions.
42?
30, 32.
32. Oh, I thought we only had 26 on the review.
The review is 26. See, yes, 26.
Yeah. Why, hold on, I'm still trying to get mine open.
26.
I think this is going to take us a while. Okay. Okay. So the question number 2, give a 90% confidence interval to the best interpretation. So we want to say number 2, we are 90% confident.
Yes.
The true mean, yes.
Mhm.
That is.
Okay, number 3. Oh, I got to go back to my mark. Hold on a second.
Yeah.
Number 3, I got the third one because in the distribution of mean of each sample is normal since the data have to be normal.
Uh, that's where I have doubts because the sentence says that the QQ plots are approximately normal.
Yeah.
So
Yeah, on this one I was confused because each of the samples seemed like they were net less than 30, and so I've actually put no. It's not normal since the sample size is not large enough because the first sample is 20 and the second sample is 15.
but they are not.
Does it say there that they're normal? Or is it
Yeah.
Oh,
Yes.
okay.
So I was thinking that was yes, the distribution of the mean of each sample is normal since the data have
Oh,
to
I
be
see.
to be normal, the fair one. But I don't know. I That's where I get confused on that concept.
Yeah. Okay. Sorry, I didn't see where it said at the very end there approximately normal. Um, the distribution means that each sample is normal since the data has been determined. All right. Yeah. Then I guess, or it's central limit theorem,
But for limit theory, it doesn't have to be
but
large.
yeah, it has to be large, right? So I think it might be 3 as well.
Yeah, could be three, could be one.
Let me see here. Central limit theorem.
Because I remember we had a question very
Mhm.
similar, no? I will.
Yeah, because we already know that it's normal, right?
Mhm.
Not because of the size, but because they said it's normal.
Yes.
What do you think, Brianna?
I think it's the third one.
Yeah, that's what we were saying. Yeah, they're okay. Of the 4 types, number 4,
Yeah. The difference of means, the fair one,
these are because are they dependent?
they comparing how you respond from a stimulus. Stimulus. How do you pronounce? Stimulus?
Stimulus.
Stimulus, yeah.
Stimulus, yeah.
Stimulus.
Oh, let me see what I put on this. I feel like I'm looking at this for the first time. Um, what I had was in my homework was confidence interval for mean of differences using dependent samples. Um, but
The
after I
fair,
went through a little bit more, I was getting confused when I
yeah.
started reading. What did you guys get on your homework?
I was thinking on number three.
I was thinking the second one.
Okay, we all got different ones. Okay, we better read through this one more time. Let me read through it. The four types of confidence for this experience.
This is for the difference.
Differences.
Because it doesn't say the means are different. They could possibly be the same or around the same.
Yes.
But I don't know.
But we have to use dependent samples or independent samples.
Um, so they wanted to read whether reaction times. So the male's different from that of female, so that makes it a dependent because they couldn't do this test without both if they want to compare it to both.
As far as the
So they
first one.
depend it on so the researchers ran. I said, okay, and so confidence
Right.
interval mean of differences using dependent sample confidence interval was unknown because it is a null interval.
I think so. If they are dependent, yeah, we need to use the first answer.
So, but we don't know what the mean is yet, right?
Yeah.
Because and we don't know what the standard deviation. So I think it's going to have to be, yeah, the first one because, well, confidence for mu when, so we don't know what the mu is. So we know it's not three because it's not independent.
Yeah.
What were you thinking it's number two, Brianna? Say it again.
Yeah. But I don't know. I don't really have any background on it other than you don't know the. I just.
The standard deviation, right? Because we don't know what that is. But we also, I don't, yeah, because we
And
also
that's what
don't
you.
know what the mu is either. Yeah. So I I believe it's still going to be number one.
Yeah.
Is that what you were thinking, Mariella?
Yeah, I'm taking number one because as you say, no, it's dependent. So for me, it's going
Hmm.
to be this.
The mean of differences. Yeah, because we don't have the data yet to. Oh, I see what you're saying. Because if we did have the data, then it would be you and yeah. I think what we could do is see how we do, right? How many times do we get to take this quiz?
I think.
Um, I don't know. I think that's two.
I think okay. Well, let's try that and then we can come back. It's tricky because you got to really read through these carefully, right? Can't be
Yes.
rushed.
Because
Um,
as I told you, when I did homework quiz, I
mhm.
did twice because I read it first. This is when
Yeah,
when finally I got five wrong, but where they are wrote written like this, no? When said
yeah,
I
you have
read
to.
down, I read carefully. No, it's that. That's so confused. Have to
Okay.
be careful. Yeah.
Have a researchers interested in estimating savings account balance.
Yeah, let's go to number five.
Yeah.
I think it's the last one.
Chief, let's go.
Um. So yes, I agree with you. When I was looking it up on the lesson, I think this is covered in lesson 10. And if your sample size is larger, then your margin of error should be smaller. Was it lesson 10 I saw this in? If the sample size increases, width of the confidence level will decrease. It will become narrow. That's so yeah, I agree with you. The last one. Is that what you have, Mariella?
Yeah. Well, we're number 5.
Yeah.
Let's see.
Go back to my homework.
Or let me say it's
Huh. We didn't do number 6. I'm gonna now we gotta do that one because when
what
we
is
did this
the
question in the homework, it wasn't for the margin of error.
what is
Tricky
the
guy. Back to the color. So
uh
let's.
99% computer 99% rather than 95.
So
Computer 99% confidence interval rather than 95 confidence interval.
if you do a 99%, because your confidence interval gets smaller at 68%, I mean, your margin of error, 68%, then 95%, and then 99%, right? So, so 99% would actually make your margin of error bigger.
Bigger, yes.
Yeah.
Yeah.
So we want to know how we can get our margin of error smaller. And so we would have to have more, because right now we have to have a bigger sample size than just 30.
Yeah.
Get 90, it'll get smaller.
I would know one of these answers.
Mhm. I know. Well, so in the homework, when I looked it up, I came up with obtain the balances of 90 bank customers rather than 30.
Okay. Larger samples.
Yes, larger samples.
Yeah. Quality assurance in general factor need to estimate truthfulness.
Okay, so this one, mu is we have to find the margin of error. 75%. So
The mean is mean
mean is 1,000,
1000.
and the number is 4.
The
95.
deviation is 2.
So E B squared D. So I have 1.96.
That's what I got.
Okay.
How you get it that?
So got that by doing um 95%, which is 1.96, right?
Yeah.
Multiply the standard
Um,
deviation divided by the square root of the sample size.
yeah.
100.
Yeah, okay.
and then I done this before, so the lower bound I had is 998.040. Is that what she had?
What was it? 998 point.
040.
Yeah, I think that's what I had.
And then the upper bound was 1001.960.
Yeah.
Is that what you have, Mariella?
No, I don't. I haven't done that. But go ahead. I will do it after.
Okay. Sorry. And then question 9, I have 38,416.
Yep, that's what I had.
Mariella, let us know if you need some help on that one. Do you know?
Yeah, I was trying to do the number 6, 7, and 8
Okay.
myself. Yeah, but I will let it. I will follow you number 9 because we are going to be. I'm
Okay.
going to. I know what to help. Yeah.
Okay. Okay.
Mhm.
And then,
Yeah, what's the question? There's a number should
So
be.
I don't know if I did this other one correctly. Let me do the next one. Let me just do it quickly again because I just realized. Oh
with
no. Okay, so I had that the
What number? Number 10?
number 10.
I
Okay.
think it's the
Let's
last
see.
one.
Yeah, the last one because it's just wanted to know the what the
Well, it's just the Nolan alternative, but it says the department thinks they're smaller than, so.
yeah, that's
Uh-huh.
what I had.
Yeah, the apartments
Yeah.
are smaller than advertised.
Yeah.
Yeah.
So in a statistical test of hypothesis, we say reject the null hypothesis from the level of significance A if the p-value is less than A. Because
Yeah, if
we
you,
reject.
Let's
Yeah.
just, yeah. Reject the no. Yes. I read the statistics. If they say that it's bell shaped, we can consider that it's normally distributed. Yes.
Yeah, but ANOVA, see, on this question, when I was looking at, because the ANOVA is the right skew test, right?
Yes.
It's
Uh-huh.
never a bell shape.
Bell shaped. Yes.
So I put, let me look back at my homework here. Um, see, on this one, I wasn't 100% sure, but I put that they didn't have enough data. No, they don't have enough data, but I'm just looking at it again. It's so different when you look at it in a quiz, then it becomes more, I don't know, real, I guess.
We don't have enough data.
GPA for the house. Because in a NOVA test, do they need to know the true standard deviation? I don't think they do, right?
Yeah, but yeah, they would use ANOVA, yes. No?
Well, it says we can conduct ANOVA testing when the following three requirements. The data normally distributed, and that would be right with a bell-shaped.
Mm-hmm.
When I first looked over it,
Oh,
I
I
picked
see,
the
see,
third
see.
one.
Number 12, no? Yes, it's
Yeah.
not. No? The variation is not online. The
Or
sample value.
nearly equal.
Yes,
Yeah, yeah, I think you're
yes,
right. I think I
yes.
was wrong in the homework because the variances do have to be equal and data has to be normal. Check Q plot. Yeah,
Okay.
yeah. We'll go with number 3. Came in across such as so on this one, I put in type 1 error
That's what I put.
because
Yes, they
because
want her. Yes.
originally rejected
Yeah.
and then she came back and found that it was actually true.
Mm-hmm. The level of significance is made very small. You know, very very.
For 14, I put the first one.
Correct, because
Okay.
it's
Yes.
always opposite, right?
Yeah.
Yeah.
If
They're
one
opposite.
goes up, the other goes down. Yeah,
Yeah.
that's
Yeah.
yes.
That's nice. I need to continue.
I put that you reject the null.
Yeah.
That would be the last option.
When I did this, I came out with a p-value of 0.0388. So
Yeah.
you would reject the last one. Is that what you had too? So
Yeah.
was it? Yeah.
Your theta, how much is it? 1.765? No?
1.765 is your what do you call it again? Yeah, that's what I have, but then you put that into the so that's your Z score of the sample.
Or, yeah, C
Yeah,
score. To
and then
determine the p-value, no?
you put it in the app, the normal distribution or probability app, and then you get 0.37. Let me show you on my screen. So then you stick it in here, 1.675,
Mm-hmm.
765. And then
Seven.
that's how I got here because it's greater than, right? See, I always get mixed up with when we're looking for greater than if it's supposed to be equal to and greater than or just greater than.
Okay.
Can
Yeah, but
somebody, you guys know how do you know which one to highlight?
For what?
When it's
Oh.
saying that is it just the greater than? Is it just this side? Because I always get mixed up. See, that would have been too high.
ah,
But
yeah.
I always get mixed up, when the question is, because
Mm-hmm.
in this question
This question is
is the hypothesis is that it's going to be
greater than.
greater than, greater than. So it's just me, because sometimes I see this done equal
Well,
to greater
the
than.
equal to is from the red between the red.
This
Yeah,
is equal to, right?
Yeah, and so greater than is one side and less than.
Okay, so it's always going to
No,
be
I've
this.
always
Okay.
taken it. I don't know if that's wrong or what, but
Yeah, no, that's what I'm always confused about. So, okay, that and then that's definitely how I got that,
yeah.
which
So
is less than point 0.5.
reject reject the hypothesis.
Reject it, yeah.
Mhm.
Which is the last one, right?
Mm. It's not the first one.
No, that's reject. The first one is reject the alternative. The
Yeah.
last one is reject the hypothesis. See, that's where we gotta read this because let me stop sharing my.
Mm.
Oh well, I'll keep sharing my stuff unless if somebody wants to share theirs. Um, so you like to the number no number 16 here.
ANOVA.
So on this one, we just by
Mm.
male and female students, so it's just the two, right?
yeah, but you're
Independent.
you're not trying to find the difference between them, right? So independent samples or
And then sample test because pair or not.
Oh, I see what you're saying. Well, because it says T, and I was thrown off because of the wording says you'd like to random sample 100 for each group and test if those means are different. Um, so I did the paired sample t-test, but so
But
we
there
would so in this case we would do a independent sample for each one
mm-hmm.
and then compare it, or because
Compare.
I got it. Okay, so you guys are selecting number two, huh?
yeah, I think so.
But sample t-test, independent. What is an independent sample t-test?
That one have an X here.
I- Is that our because we have a one sample test t-test, paired sample t-test. So would it either be a one sample t-test or paired
You
sample
have two
t-test?
samples, right?
What was that?
You have two samples.
Ah,
Yeah,
yeah, we
so
have
then it would
one
be a
sample
paired,
there and
right?
two ANOVA. But there
Because
is one called independent, no?
yeah, because the okay, now I'm confused. So so if we're doing the differences, wouldn't we do the paired sample t-test?
There is an independent sample test. Where is the other one? Mm.
Okay. Okay. So are you guys just doing the independent sample t-test?
I was thinking there could be one sample test. The last one?
You like to sample
You just
each group and test
all
if those
you have two samples and they're independent, so they don't you're not trying to find the difference between them, and that's what you do in a pair.
Right, that's what. Just to give a name, no? Now, because I was looking as Mitzi, the Excel of quantitative inference,
uh-huh.
and when you see the Excel, you have four types, no? One sample t-test, pair sample t-test, two sample t-test, and ANOVA. And I would choose one sample t-test, but they have to be independent for each group. No?
Okay. Okay, so that's what we're saying, independent one sample t-test. Got
Uh-huh.
it. Okay. So number two. Okay. All right. Okay. And uh
Entonces, in academic achievement by males and female within, she decided to use brothers and sisters.
So on this one, I put number
Only brother and sister, but
Dependent. It's like that one that was in one of the quizzes or something about the wife, and I was so confused because it was like it was dependent because if you chose the husband, then you had to use the corresponding wife or something.
right, because
First, I thought it was independent because like they're different people. They shouldn't.
right. But because she's trying to find out if
They have to find a brother and a sister.
a
So
brother and a sister, so she's being real specific what
Yeah.
she's testing to. So it's number 4. It's the last one because if you
you
select the
select
brother so as to compare his academic achievement to his sister, you must include the sister in your study. So that's dependent. Um, okay, so
yeah.
use the following information. I'll keep sharing my screen because otherwise you're just gonna see me look at my screen. Anyway, okay. Researcher that can check night. So for this one, what did I put earlier?
Okay. Okay. This of organic. We're select to
I was
control.
confused about this one too. I put confidence interval for mu when standard deviation is unknown.
That's what
So I put the first one. Is that what you guys have?
yeah.
Okay. I just going to copy on my one sample test.
Huh? Are you below us? Are you below? Okay. Which of the following 90? Oh, did I even do this? Let me look. Test. Okay.
Okay. Determine the margin of error. It says.
Okay, so yeah, I was confused about this one. So we take the data here, and then we need to, so the margin of error
Mm-hmm.
is obtaining
High,
we have
low.
to obtain the confidence level, the standard deviation, and the number, right? So, okay. Okay, I see it now. Okay, so we put it in our. I just didn't
I got
go far enough. So you got standard deviation of 4.326. Is that what you guys have?
standard deviation.
Uh-huh.
4.326. Yeah.
Okay,
It's
4.326.
4.326.
Mm-hmm. And let's see. So 4.326. Let me take this out. And then our sample size was 20.
19 is determine the
Huh?
19 is determining the margin of error, I think.
Okay, is that you have? Let me just let me finish my calculation. That'll be
Oh, okay,
right.
sorry.
No, you're good.
I'm
Um,
using the Excel with one sample test.
That's what I used.
oh, you did?
Yes.
Oh, okay. Then I see it right there. Yeah. So standard deviation, margin of error. Oh, yeah. Okay, so it's all there. So N20 mean is 13.193. Oh, whoops. B, B. Oh, okay. So you have 1.8896. Is that what you said you have?
Yes.
Okay. Yeah, that's what I have.
For what?
For the margin of error,
What did you get?
1.896.
Uh, well,
Oh.
so
Oh, is that not what you get? Hold on, let me see. 95 type of test is
well, you remember that video you and me watched, Mitzi, where you take the higher bound confidence error minus the lower bound divided by 2.
right, right, right.
Uh-huh.
So it's 15.217. Is that what you guys got? Minus 11.168.
Uh-huh.
Let me go back to this.
Is
So
0.049 divided by 2 is 2.025.
Yes. 2.025.
15.217 minus 7.168. And then you just take that divided by 2. 0.025.
And what are you using to greater than or not equal?
Do you think that that may be
Nothing. No,
because that does affect it, right?
yes.
No, it doesn't affect your confidence level. It just affects your p-value. So you got
Yes, 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 yes.
2.0245 then on the margin of error, Brianna.
Yes.
2.025. Yes.
2.025. Input lower bound, which is 11.18 or 168.
Mm-hmm. 168.
And then upper bound is
15 something.
15.217.
Oh my gosh.
Okay. Okay. Difference in mean for Hummer 1 and Hummer 2.
I don't know how we want to know if there is a difference in mean. Listing prices. Yeah.
One that's definitely used the 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 paired sample test, right? And I'm just doing it again. I just want to make sure. I feel like I'm so unsure. So we're gonna take the Hummer one and the difference in meat. It's gonna be interesting. So, oh,
We have to
shucks.
use pair sample test there, no?
Paired sample test. Yeah. But the thing is, difference in mean, difference in mean. So we're taking the first one and subtracting the second one, right?
Yes.
But it's funny because for the first one, I have only six sample size, and for the second one, 88
Sorry? Six what?
sample size for Hummer one.
For Los Angeles?
I got
Oh, shucks. Okay, never mind. Let me go back. Los Angeles.
I got
Oh, yeah, for Los
like
Angeles.
like 63
So
for
how many for Hummer one? We're looking at the model, right? H1 and H2.
yeah, because they don't discriminate.
Oh, we're looking at the like on the last column there's city, so then you pick Los Angeles and then
I'm
Oh,
looking
oh,
I'm
I
looking
see.
to
I see. I see.
I have like 108
and 63.
and 63. Uh-huh.
Okay, let me.
108 for Los Angeles and 63 for New York. But if we use paired, we don't must compare with the year and the model.
So New York, Los Angeles is our first group, so it's going to go in the front, and then New York is going to go in the second, right?
Yeah.
Okay.
But what I'm saying is that we are using the sheet that says pair sample t-test, no?
Yes, that's what I'm using. Please tell me I'm using the right thing, because
The what? The paired sample?
yeah.
But why? But we have different quantities and we have different conditions because we have hammer H1, H2, different years.
But I think they're only wanting to know the pricing from both cities, right?
Mhm.
So how many did you have for Los Angeles? You had 108,
Mhm.
and then for New York you had
63?
63.
Yes.
Okay, all right. Okay, then I'm on the same page. And Los Angeles is going to subtract New York, right? Become okay. So back to the quiz. Now I got it set up right. Four times confidence intervals is which is a perfect situation. Um, so mean. So for number For number 22, do you have the second one? Confidence interval for mean of differences using independent samples.
Mm-hmm.
Number 2.
Number two dependence on. But I don't know, but what I am thinking that must be two samples
Okay,
or not.
I think
what?
they're independent because they don't rely on the other one to have that, right?
I have some doubts because, as Brianna says, no, we have, for example, in one side we have a GR 2006, and the other side we have 2003. So I don't know if it's right to compare because here we are making difference, no? We are subtracting the price from another, and obviously, if we have a year different from the other one, we're going to have difference. And also in the models, my doubt is, in this case, it's not better use two sample test.
It's better or it's not better?
It's better two
Yeah,
sample instead of pair.
two sample. So you're saying that use a
But
two
we are
sample
comparing.
t-test?
But we are comparing, no? So that's what I'm.
Yeah, because oh, okay, I see what you're saying. Because we want to know the difference in the mean listing prices between the Hummers and in Los Angeles and New York. So if we want to know the mean and the difference of the mean, then they have to be dependent on the data has to be dependent on each other, right?
Yes, yes.
Because we're matching the pairs. And
Mhm.
so
We are
it's
not matching anything
it's
there.
it's one population of Hummers, but we're taking it two different observations, one from New York and one from Los Angeles,
Mhm.
on individuals selected sample to participate in the pre-test. So that's why I thought that they were dependent on each other because um, we couldn't have a difference in the mean listing of the prices if we didn't have
Mhm.
both data sets. Let me see. Yeah, because we have to pair it, right? Because an independent sample would be that they could stand on their own. Okay. So, but you're saying they're independent because can you?
Well, they don't rely on each other
Mhm.
to get the information. Like you can find either the Los Angeles price or the New York prices no matter what.
Yes.
Mhm.
Like you don't need to know like when that one question you needed the brother and the sister because like you needed to find that pair because they relied on each other. They were
Oh, I
connected. But
see.
these have no connection in between them.
Hmm. Hmm. Okay. Okay.
Okay.
Okay. All right. That makes sense. So then to answer the question, then we would be looking at number 3, right?
Yes.
Confidence interval for the difference means independent samples. Okay. All right. And then the 99. So then we're not using like what you're saying, Mariella, then we're not using the paired sample test. We're using the two sample tests.
Yes.
But we kind of still have to use this paired sample test, don't we? Because
Well,
we're trying to look at the
we still use
differences.
the paired sample test because you're still trying to find the differences.
Yeah, we're still trying to find the differences of both. So for the next question, the lower bound is
Yeah. If we use pair samples, no,
yeah, the paired
we
sample t-test,
649 negative.
negative 649.052.
Yes.
Yeah, that's what I have. That's what you have, Brianna.
That's what I had.
Okay. The upper bound. Where is it? 7,279.
Yep.
0.783.
Yeah, 0.783.
Okay.
Recibe las cositas. Exercise bone density.
Okay, so the question is,
Yeah, there were 3 groups. I think that was on homework.
I think it's ANOVA.
Yeah, ANOVA, huh?
There's 3 different groups.
Mhm.
And you can't do that with any other one, so
Yeah,
yeah.
it's ANOVA. And then there's a- This.
Ya. Pero me lo pone ahí tapetito primero.
High jump. Okay. Hi. Yeah.
¿Qué tal?
Estoy. I got for TSS.
we did wrong. But for number 23 and 24,
Sorry?
on 23 and 24, we put those answers, but then like I'm going through the review at the same time, and there's like multiple choice for those answers, and our answers don't like correspond to the multiple choice.
In the homework?
And like no, looking at the quiz and then looking at the review, that we
Yeah. I
The
will check.
23 and 24, you said?
which corresponds to number 18 on the review.
18.
Because there's all those and we don't have.
Oh. Yeah,
That's
well,
what I'm talking about.
Brianna, if you use 2 sample test, you have the answer that would be letter C.
Huh.
Really?
Yes, because I copied to both options, to pair and to sample tests.
Yeah.
And if we look the options, as Brianna says, it appears for the answer for 2 sample tests.
Okay.
Yeah.
Well, sorry we doubted you, Mariella.
I know.
Jeez.
I just copied to the both sheets.
And
Because
it's
I was
90
thinking now, because I couldn't compare for the years, the models. So it's going to be
right?
423.238.
23. Yeah. Yep, I see that now. Negative, right?
Negative, yes, negative 423.238, and the upper is going to be 5417.336. And the other one, and the margin of error so is going to change.
Yep, you're right. Margin of error is going to change. Oh,
We don't need to know the margin of
yeah, I
error.
was going to say, what do we?
Yeah. Oh.
What
Okay,
are you
good
guys
catch.
talking about?
Good catch. Okay,
Okay, yeah, let's go with ANOVA.
and back to the ANOVA. Then we have to.
But for that one, I got 7.978.
Yeah, that's what I have.
For the test statistic, and for the p-value, I got 0.002.
0.002, yes.
Let me see. Yep.
Sweet.
We have to check all the questions and
I know.
before to submit them.
So 0.002 is low, so there is sufficient evidence to conclude it. Yep. What's our
Guys, there is the option.
I think it's the
So-
third one.
the fourth one?
Fourth one.
Yeah, there's sufficient evidence to conclude that the mean bone density of at least one group, right,
Yeah.
is different from the mean. Okay. That's what I have.
The first one?
The fourth one, because we're rejecting the null hypothesis.
Yes, we do yes no.
Yeah. So
At least one of the groups, yeah.
yeah.
Okay, yes.
Oh, we did this one.
I know. I can't remember when we did it though.
It was in the homework.
The reply cost.
I don't remember which section.
Bless you.
The red fly cost. I did it.
Yeah, shucks. Okay, now let me pull it up again.
Oh my gosh. Okay. The lowest price. Yeah.
Did we do it in a quiz?
Yeah, we did it in a quiz. This I don't
Oh.
remember. I don't remember if we were.
I think it was. I think it was
Homework quiz.
homework quiz. Yeah.
Yes.
I don't know what quiz.
Yeah, but the first answer is ANOVA.
Because you can look back at your quizzes. Oh, I found it.
Yeah, you can look back.
Yeah, I just didn't know which. So it's a paired sample t-test.
Yeah. Yes.
But
That
does
is
it- Good thing
Yes.
that's not an option in the quiz. Oh my god.
It's lesson 13. Yes.
Yes. And so 13 is independent samples. So it'd be an independent sample test.
The first one.
Yes.
From hypothesis. Calculate the statistic.
And then the p-value, or we don't need the p-value. Oh yeah, we do. Is 0.
Lesson 13 or lesson 12 was? I don't know.
The lesson 13 homework quiz.
Yeah, lesson 13. Where is here?
Lesson 13, you said?
Yeah.
Okay.
I mean, it doesn't really give us anything other than test and the p-value.
But here doesn't say per sample, so dependent sample test.
Well, the chapter 13 is
29,
independent.
question 29. What did you answer in question 29?
Independent samples test.
Independent?
Yeah.
Yeah, because the 14 days in the
The question is
And then I'm putting in a paired sample t-test.
wait a minute, I'm confused.
yeah, because it's similar, but it's not the same. Huh?
Wait, yeah, so we're 90 days and okay, we got, and then we're using the paired sample t-test for the, okay. Hmm.
T statistics. You have 1.685.
I'm almost there. Okay, so 1.685, that's what I have. Is that what you have, Brianna?
Yeah, 1.685. And then the p-value 0.048.
Huh?
We're
P-value?
seeing,
You're using a level of significance of 0.90.
90.
yeah, because the 10.
Ah. Yes, 90, no?
Sorry, you said your p-value was 0.0.
48, and I don't know if that's right.
I have point
Zero,
0. I have
9.
0.01.
I have 0.096.
That's
Yeah.
what I put on the quiz, but then I looked back at the quiz and they used a level of significance of 0.95. Or I don't know how I got something different on that on the
Because
quiz.
this is, oh,
Because on my quiz I got a p-value of 0.0962. But
I got 0.96.
yeah, that's what I have.
on this test,
For the p-value, 0.096.
I don't know
And
why.
in the homework quiz, I put the same.
Yeah, me too, but I just don't understand why I'm not getting.
The type of test What are you putting in type of test?
Oh, my type of test was greater than instead of not equal to.
Not equal to?
Yeah, so I got 0.096.
Yeah, I put not equal to, Jesus.
Okay, so level significance is 0.1, so it's lower. We reject the null. So there is sufficient evidence. What's the question again? Difference, I mean. So
There is
number 2, right? Because our hypothesis is if there's a difference in the mean cost of nonstop flights tickets for 14 days compared to 90 days. So our null would have been that 14 days compared to 90 days is the same, that there's no difference. And then our alternative is that there is a difference, right? And so I have
second one?
2, yeah, that there is sufficient evidence to conclude that there is a difference.
Oh, we're finished, yay.
Yeah, well, here we go. Moment of truth, right?
I won't go because I have to answer 2 questions before.
What you want to review it one more time before we submit, or just submit and then?
Just a minute, because I have to develop the questions 7 and 8. 7, 8, and 8.
All right, I'll let you know what we got wrong. Okay, let's see. So we got number 4 wrong. And
number 4. Why? With that sentences, I got confused, really. I had to thinking and thinking just to have the logic.
And number 29. That's it. Just number 4 and number 29 is what we got wrong. So
I think 29 is dependent samples.
29. Let me go back to 29. It says, what is the correct hypothesis test for the situation? We put independent sample test. What's funny is we got all the right, everything else right on that.
Okay, so then I submitted it and I changed it to dependent. And that's right.
Okay.
And then I changed number 4 to the second one. What did you have?
We had the first one.
Yeah. That's what I thought. So I changed it to the second one, and that's wrong also.
Okay, so then this one. So
maybe it's going to be the first one.
No, so it's not the first one, and it's not the second one.
The third one. Sorry.
You think it's the third one? Hold on. Using independent samples. Hold on. Let me look back at the question.
I have to go to work, so.
Yeah. Go ahead.
But we did good.
Yeah, we did
this week.
We did really good. If we figure out number 4, we'll let you know.
All right. Thank you.
Okay.
See you
Thanks.
later.
Bye, girls.
Bye. Okay, Mariana. So.
I will review my questions numbers 8 and 9.
Okay. All right.
Okay.
Do you need help with it?
No, I will check the lessons just to look that the numbers that goes with 90%, with 95 and 99.
Yeah, 8 and 9. Oh,
Because there were like numbers just to multiply when we have different confidence interval, no? So
8 and 9. Oh, I see for the upper bound and the lower and the margin of error.
yeah,
So
I'm looking the
yeah,
less. I'm looking. It's lesson. What number of lesson was
this
that?
one I think was lesson number um confidence intervals.
The confidence was number 10.
I think it was. I want to say it was number 10.
Oh, we checked it.
Margin of
Ah,
error.
yes,
Yeah, yeah.
yes.
And remember, because it's 95. Margin of error would be 1.96 multiply standard
Okay.
deviation divided by the square root of the
Okay.
sample size.
Yeah, I have to do that.
Yeah, and then the confidence level would be, so I just use, because I have it in my formula here.
Yeah, I did my formula, but I was looking and I lost. You, and you were talking, I was looking, but I think that I forgot to save because I lost all my formulas.
Oh, I see.
Yeah.
So this is the one I use.
Yeah, I
So
have a chart like that
yeah,
because
so 95 is 196. What was the thing again? It was
the mean was
let's see.
1,000
So the standard deviation was point
to
0.01 less than 10, 0.01, and then the mean was 1,000. You said, oh, was it the G E2B G? Was it 1,000? Or no, it was 1,000 here.
So I'm checking again the lesson just to understand. Margin of error was to n. Don't worry, Mitzi, I will check it by myself.
Okay, all right.
Hmm?
But oh yeah, no, that was it right there. So that's how. Anyways, that's how I got it. It was
Yeah, yeah.
taking.
I have my chart, but
Yeah,
I think that I didn't save because I was looking and I get lost.
right. Okay. All right. Well, let us know if you need anything else, if you need any other help.
Okay,
So,
thank you, Mitzi. Thank you so
okay.
much for your time.
You're welcome. You have a good day.
You too.
Thanks. Okay,
Thank
bye.
you. Bye.